Good morning to one and all. So in this lecture, we would like to discuss about the concept called D flip-flop. So in last class, we discussed about SR flip-flop. So here we can observe that SR flip-flop. So where SR flip-flop here set and reset. So in this particular condition, when clock is equal to 1, when S is equal to 0, R is equal to 0, it means that there is no change state. So it means that, so we can call that as memory state also we can call. And in particular case, S is equal to 0 and R is equal to 1. So we can say that the state is reset state. And in S is equal to 1 and R is equal to 0, we can say that it is a set state. And in both one case where S is equal to 1 and R is equal to 1, so this is intermediate case. And irrespective of the particular S and R, meanwhile a clock is equal to 0, it means that no change. So from this SR flip flop, we can say that, so here we can understood that from this particular, I am highlighting one point here. So here you can say when S is equal to 0 and R is equal to 1, and S is equal to 1 and R is equal to 0. So here simply we can say that S is varying from 0 to 1, and in the similar way R is also varying from 1 to 0. So therefore instead of having two input lines, for getting this particular output as reset and set, simply I would like to have a single input called D. D is nothing but data. So from the SR flip-flop we can design D flip-flop. So simply instead of having two input lines, we can keep one single input line as data. Say for example, if my D is equal to 0 is giving at this particular input pin as set, and the other pin it obviously should be as 1. Why? Because in this particular condition we can say that S is equal to 0 and R is equal to 1. Therefore S is equal to 0, R is equal to 1. Therefore I gave you D is equal to 0. So this 0 is directly moving to this particular set, and this particular state is going with an inverter. So this 0 will become 1. So like that I can design my D flip flop. So simply SR flip flop can be designed by D flip flop can be designed by using SR flip flop. So here you can observe the basic building block of the D flip flop. So here I have two input pins S and R. So for S and R, simply I kept D as directly connected to the S, and D is connected along with the inverter called is R, and I got my outputs as Q and Q bar. So in the similar way, directly I can have my D flip flop logic symbol. And you can observe the similar logic diagram for the SR flip-flop and as well as the D flip-flop as I explained here. So simply I would like to connect one inverter for the R terminal, and S is connected directly to the D terminal, and as well as clock is my one of the input for all the flip-flops. So here I am considering my clock signal as positive edge triggered. So we can consider in the place of positive edge triggered, so we can consider as negative edge triggered also. So negative edge triggered is shown like this. So we can consider either positive triggered or negative triggered. So from this particular point of view, so we can say that S is equal to 0 1 and R is equal to 0 1. Okay, so let us consider initially D is equal to 0. This is my first case. So if I gave D is equal to 0 here, so this 0 is directly coming in this direction, and for this first gate, and this 0 is coming in this direction, it will become 1 here. So now if you consider this as S star or S, or else you can consider this as R. So S is equal to 0, S is equal to 0 and R is equal to 1. So S is equal to 0, R is equal to 1 means what you can understood from this particular point is reset state is occurring. Therefore I can have my reset state. And in the second condition, if D is equal to 1, if I consider D is equal to 1 with another color I am showing, so therefore S is equal to 1, and this 1 is coming in this direction, therefore R will become 0. Therefore 1 0 condition. So here 1 0 condition, you can observe that S is equal to 1 and R is equal to 0 means it is set state is occurring. Therefore I can have my set state. So directly I can say by using SR flip-flop, that is called D flip-flop here. So now these are the conditions I explained here. D is equal to 0 and D is equal to 1 when always my clock signal is equals to 1. So this is positive edge triggered. Okay, my q is changing from 0 to 1 and 0 to 1, and my next state can be represented by qn plus 1. So reset means my output is always getting 0. Set means my output always getting as 1. And the last condition here you can observe that, so my clock signal is equals to 0. When my clock signal is equals to 0, it means that irrespective of the data input, my next state is can be given as memory state. That memory state can be given as no change. So the previous input is keeping as in the memory as it is. Okay, so that is what memory state or no change state. So this is what the concept regarding to the D flip flop. Okay, in the next lecture we will discuss about the concept of excitation table and characteristic table and their corresponding expressions. Thank you.